To have more grip, you will use a softer tire, right? Wrong. A softer tire lasts less but has more grip, and a harder tire lasts more but has less grip. I'm sorry guys, but it doesn't work like that. Things are a little bit more complicated. Let us discover how it works together. Tires are a crucial component of the motorcycle. They have a huge impact on the vehicle performance. During my first days of work as a MotoGP young vehicle design engineer, I noticed that the MotoGP tests were not so frequent as I thought. So I asked to my boss why we didn't perform more tests during the year. The first reason he came up with was that the number of tires available are limited by regulations. So I immediately replied by asking why we don't simply use the best tire that we can find. I mean, it is better than nothing. But he replied to me that it would be a loss of time and money because when you change the tire, everything changes and you are not going to understand anything. So you can have an idea of the fundamental role that this component play on the vehicle. In fact, they are the real connection between the ground and the motorcycle. They are made of synthetic rubber, natural rubber, fabric, wire, along with carbon black and other chemical compounds. They have an internal structure that is specific for any use, and this structure is responsible for the performance and the mechanical properties of the tire. A very important property is the stiffness of the structure, since it will provide different dynamic responses when the tire is under load, with a huge impact on performance. Inside them there is pressurized air, and you could be thinking that it is thanks to the air that the load is supported. Actually, the task of the air is to put tension on the tire structure, which is the part that is really bearing the load. So we can consider the tire as a tensile structure. As we said at the beginning, you could think that the softer is the tire, the more grip is available. At the opposite, the harder is the tire, the less grip you have. As we said at the beginning, this statement is wrong. There is of course a relation between the capability of the tire to cling the asphalt and its softness, but it is not the most important parameter that influences the grip. The key parameter for this phenomenon is called hysteresis, or imperfect elasticity. The hysteresis is a property of the rubber, and it is an energy dissipation mechanism. While rolling the tire absorbs some energy due to the deformation, but then it does not give all the amount you get, so there is an energy that is lost in this process. So it increases the rolling resistance of the tire and it increases the power consumption, lowering the velocity. However, it also provides grip and it has an important role in the heat exchanging mechanism. Let us see the consequences of this characteristic of the tire. If we could look at the pressure distribution of an ideal tire with no hysteresis, we would see the following diagram. As you can see, the pressure diagram in red is symmetrical. This condition is obtained in static conditions or with an ideal material. If we now look at what happens in a real case when introducing hysteresis, we see that the pressure diagram is not symmetrical anymore. As you can see from the picture, the resulting reaction R is not aligned anymore with the center of the wheel. This, of course, generates an opposite torque, which slows the vehicle down. As I said, hysteresis generates grip, and we have seen its macroscopic effect looking at the entire contact patch. This effect can warm up the tire to the most internal part. There is also microscopic hysteresis, which is due to the asphalt roughness. This part can warm up just the external surface. It is interesting to look at grip with a magnifying lens to see what the mechanism behind each are. Grip is generated by three effects: deformation, adhesion, and tearing. To understand the role of any contribution, let us study this example. We have a piece of rubber. the contact patch of our tire that is sliding on a surface, the asphalt. Zooming into the interface, we can investigate the three effects. We begin with the deformation. Because of hysteresis, once again, the center of pressure is not symmetrical and it generates an opposite force that obstructs the motions and creates grip. Let us look at adhesion. This time, the phenomenon is related to the chemical interaction between the two surfaces. They exchange forces called van der Waals forces. This is another factor that generates grip. When looking at the last contribution, we have the tearing. In this case, we see that the rubber is ripped by the interface and thus dissipates the energy, providing grip. This phenomenon has an interest only in very soft racing tires. To summarize what we have seen, softness is not the most important parameter to have grip. Moreover, you have understood what grip actually is. If you like to keep increasing your understanding of the motorcycle, keep following our videos. Tomorrow you will receive a new one. Thank you, goodbye.